several publications to his credit. His area of expertise is in municipal and hazardous waste treatment, land engineering, waste to energy system, water and wastewater treatment technologies. Sir has a wide experience in all fields of environmental engineering related to water, wastewater, solid waste, etc. So I think we are all very blessed to have him deliver the talk today, which will give us a lot of takeaway. And for you, especially research fields where you can work in future. So without much ado, I would like to hand over the platform to Dr. Lakshmikanthan C P to deliver his talk. Please take over, sir. Thank you.
Thank you, ma'am. Thank you very much for the introduction. So I would share my presentation now. Yeah, are the slides visible now?
Yes, sir. Slide is visible.
Hello?
Slide is visible, yeah. Sir.
Okay. So, okay, thank you. So the topic is design aspects of solid waste landfills. I'm sorry, the title says municipal solid waste. It's hazardous hazardous waste. So what I would do is I would just take you through because hazardous waste is a very, very huge category, and it's a very, very huge area. So there are a lot of things that come into this category. So I'll just take you through what is hazardous waste, what are its characteristics, what are the rules, what are the regulations governing the handling of hazardous waste or disposal of hazardous waste. Then what are the if you need to have a disposal facility or a treatment facility, what are the site characteristics, and finally because it finally goes to a landfill. So what are the characteristics of a landfill, how it has to be designed, how it has to be constructed, and maybe one case study. So I'll just go through it. So this is what hazardous waste looks like. Usually hazardous waste is a huge category, as I told. It might be an industrial waste, it might be a mined waste, it might be anything. It has few characteristics, so we'll go into detail. So the top one you see is a oil and oil industry waste. The bottom one, whatever you see, is a stabilized waste. So I'll just go into detail what are all these things. Okay, now coming to hazardous waste. What is this hazardous waste? It is any liquid, solid, or gas having some properties. So what are these properties? These properties are, say, ignitability, means that it easily catches fire. If you put it in an open environment, it easily catches fire without any instigation. So that is ignitability. Then you have corrosive. It is if you put into contact with any of the metals, it corrodes that metal. It might be a storage tank, it might be a pipe through it passes, it might be anything. Any metal it comes into contact, it has this characteristics of corrosivity. Then comes reactivity. Reactivity is nothing but it is unstable, chemically unstable, and it reacts with the readily available components. Say for example, if you put some reactive material, reactive waste in an open environment, it starts to react immediately, giving some some dangerous products. It might be an explosive, or maybe some other noxious fumes that is harmful to the human health. Then coming to the toxic characters, it is nothing but it is very, very harmful to the living organisms, including human health. It might cause several problems like health problems. Maybe it varies. It even goes to the extent of mutation or genetic effects. So what are the sources of this hazardous waste? So industries are the major sources. So industries produce the greatest amount of hazardous waste. So you know that there are different industries. You take any industry, starting from the automobile industry to any chemical industry, pharmaceutical industry. You take any industry, even e-waste was considered as hazardous waste, but now they have a separate rule for that. So apart from this, you take what to say, electroplating industry, petroleum industry, any other organic industry, tanning industry, leather industry. All these industries produce what to say, hazardous waste. It might be in a liquid form, effluent form, or a solid form. So also your paints, batteries, solvents, cleaner, what to say, the cleaners, pesticides, all these also come under hazardous category. Apart from this, mining also contributes what to say, a huge amount of what to say, hazardous waste. So you know about the mining industry, right? So mining industry also contributes. Apart from that, you have small businesses that also contribute, some part of agriculture, utilities, and some demolition waste also. So you normal paint also, it is a hazardous waste. It has radon and other chemicals in that. Then coming to organic compounds, so organic compounds are also what to say, hazardous. So there are a list of hazardous what to say, organic compounds that are listed under this category. I wouldn't go into detail, but I would just give you an overview of a few things. So coming to the organic compounds, synthetic organic compounds resist bacteria, fungal, and insect activity. So these as I told, organic components or compounds are also hazardous. Some of them are like the what to say, plastics, pesticides, solvents, wood preservatives, etc. They kill all the what to say, bacteria naturally, bring organisms. Their resistance to this decay makes them persistent pollutants in the organic. So there is also a category of pollutants called persistent organic pollutants. It is called POPs. So this is under what to say, rise in the recent days. So these most of this is this category is like, some say it comes from the daily use, like we use some powder, we use some makeup items, we use other what to say, daily use items like paints or other things. So all these things contribute to the what to say, persistent organic pollutants. So the why they are called persistent organic pollutants is that they once they enter the environment, maybe say a water body or what to say, a soil or air, they don't degrade. They just stay there, causing harm. So maybe, if it is there in the water, it is consumed by the fish or the aquatic organisms, and then further what happens when someone consumes the fish or aquatic organisms through food web and food chain, it just rises in the what to say, chain. And once it enters the higher organisms, it causes what to say, terrific health effects like cancer and other things. So they can act as mutagens also. So they are obviously carcinogens and tetragens. These are what to say, a group of compounds, and what to say, harmful effects. They are having this harmful effects. Okay, all the heavy metals, they are what to say, hazardous. Say for example, some are very what to say, lethal. Lead, chromium, mercury, arsenic, cadmium, tin, copper. So that is why you have separate regulations for this, and what to say, discharge standards for this in the water or water body or on the land. So other industries, these are used widely in the what to say, wiring industry, electronics. Whatever electronics you get has most of these heavy metals. So you must be aware of that. So coming to characterization, when we talk about hazardous waste, the most important part is the characterization. So this is not as simple as the other category of waste, say what to say, municipal solid waste or biomedical waste. So you have what to say, very easy what to say, rules and regulations for that, and treatment methods for that. Maybe the quantity might be more in case of municipal solid waste, but biomedical waste, other things, you have what to say, defined methods like incineration, other things which is being followed, and they are successful also to some extent. But when it comes to hazardous waste, it's really a problematic thing, because there are a number of chemical compounds involved, organic compounds involved, metals involved, and there are different techniques to what to say, remove all these things or treat all these things, and finally what to say, put these hazardous compounds in a form, or bring it to a form which is not lethal to the environment. So coming to the characteristics, as I told, ignitability, corrosivity, reactivity, toxicity. So these characteristics are being tested. So there is a separate what to say, test procedure for all these categories, all these tests. I wouldn't go into detail of those, but I will give you a what to say, somewhat idea of what ignitability is, how it is, and all those things. So this TCLP test is a toxicity what to say, test procedure. So wherein you will come to know the toxicity level of the particular component. So this is the characteristics part. If you come to the composition part on the right side, so what it says is it's proximate analysis. Proximate analysis is what to say, you measure all these parameters, whatever is shown here. So you have the physical form, some mass balance, what to say, moisture content and total volatile content, TVS, then solid content, ash content, elemental analysis, heating value, viscosity, and then when it comes to a survey, it is a overall thing that you see directly. You can make out few things. So that kind of thing is put under the survey analysis. Like, overall description of the sample. Say you're receiving a sample, and you see the sample, how it looks, what are the components, which is physically visible. Then you go into some total organic content. Then what to say, the classes, because organic compounds, there are several what to say, classes or compounds, categories of organic waste, say alkenes, alkynes, halides, etc., etc., etc. Then any specific major organic compounds, you can characterize these compounds based on the color, form, and all those things. And then you have direct and directed analysis. So this is just identification and quantification of the hazardous components. Say how much is there, what is it hazardous or not, something like that. So these what to say, tests are very, very important when you what to say, carry out a sampling procedure in order to find out the characteristics. So these many characteristics have to be what to say, found out in order to decide the treatment procedure or the disposal method of these hazardous compounds. So as I told, ignitable, what it says is that something there is called something that is a flash point. What is a flash point? If materials that have a flash point of less than 140 degrees means it is ignitable at that temperature. So flash point is the lowest temperature at which evaporation of a substance produces sufficient vapor to form a ignitable mixture with air. So when it comes in contact with air or any what to say particular what to say, even a small spark is enough to ignite it. So examples are all your alcohols and what to say, gasoline, and what to say, your paints also come under this category. So coming to corrosivity, this applies to majorly liquids, right? So the characteristics is that pH is what to say, less than 2. It is really acidic, so it just what to say, eats away whatever comes in contact with it. And then either, if not, it is what to say, highly alkaline, means that it is the pH is more than 12.5. So there's a chart given here. I can't zoom in here, so but it is given here. So what and all categories come under what and all pH. So maybe say sulfuric acid, what is lemon juice, all these things. Then coming to reactivity, so whatever components or compounds come under this category, they are really unstable in the normal or natural environment. Like what to say, few toxic fumes, gaseous vapors, explosives. So some of the examples are like peroxide solutions. I don't know whether you people have what to say, heard about all these things. These are highly reactive. They don't remain in their what to say, original form. They react with the environment to give some harmful products. Then coming to toxicity, toxic wastes are harmful or fatal or lethal when ingested. When it goes into your body in any form, like maybe you can inhale it, or ingest it through food, or it is absorbed through your skin, or in any ways, if it enters your body, then it is lethal. You're going to have some serious effects. So maybe cyanide is one of the things. Spent cyanide solutions. Cyanide is used in a number of what to say, and other filter it through this zero point 0.6 to 0.8 micrometer glass fiber, and then analyze the sample for constituents. So when you do that, you will get a lot of what to say, results. I mean, toxic compounds. So that there is a separate standard for that also. This TCLP test is mandatory in whatever what to say, uh, compounds you get or you test, because when they try to treat it or dispose it or on land or in any other form, they should be knowing what is the leachability of the sample. So for getting the leachability of the sample, and also what are the components that might leach out of that sample, this test is very very important and mandatory. So some of the test methods are like SW846. Uh, this is like for evaluating the solid and hazardous waste. Then there are some examples, test methods given in the EPA website, that is US EPA, United States Environmental Protection Agency. Then this let's say for example you have TCLP test. The method is 1311. There are different methods for different organic compounds, because different organic compounds come and fall into this category. So you have a different test methods, and it varies from 10 to 100, right? So method 30, for example, is volatile organic sampling train. Then 31 is for volatile organic compounds. Then 40 is for principal organic hazardous constituents from combustion sources, so using Tedlar bags. So something like this. 50 is for isokinetic HCl and Cl2 emissions. So something like that you have for till 100. So you can check into this website for different test methods. Okay. Now the most important part is, before having any final treatment, there is a pre-treatment given to all these hazardous waste compounds. So we will just go through what are the pre-treatment methods that are available, and how it is done. So first comes the adjustment of the physical characteristics. So like the most important part is the particle size, precipitation, precipitation then comes the moisture content, homogeneous. Then is a viscosity, because they mentioned the multi state thing. It might be a liquid, it might be a solid, it might be in between. The viscosity might be a little higher, it might be a little lower. So this is the then comes the chemical part. So as you should pH, you have to remove the toxicity, right? Then this stabilization and solidification. These are two very important things in the hazardous waste category pre-treatment methods. So there are a number of chemical methods that are listed under this category. Say for example, stabilization is nothing but when a compound or hazardous waste arrives, it might be having any of the characteristics like ignitability, corrosivity, reactivity, etc., or it might be having multiple characteristics. So you have to stabilize them. So you have to treat via some chemical process so that it is not reactive. So some of the chemical processes are available, and you have to treat via some chemical process so that it is not reactive. So some of the chemical process are chemical reaction, acid alkali neutralization, chelation, complexation, oxidation reaction, precipitation, hydroxide, silicates, etc., ion exchanges. So these I don't want to get into detail, but I will give you some of the these procedures which are applicable to some of the waste that are available that these things. Then solidification is nothing but, if it is in a liquid form, we cannot store it, safely handle it, safely dispose it. So the solidification part becomes very very important to handle the waste. So for that, you can if you can use some kind of binders to stabilize it. So usually like they use cement based binders, then lime or fly ash based binders. Thermoplastic materials are also used sometimes. So these are all used to solidify it, and then once it is solidified, then it becomes very easy. So as I told, solidification and stabilization techniques are some of the important techniques. These are used to reduce the potential of the hazardous waste leaching, then improve the handling and physical characteristics, as I told. Then may require some pre-treatment of waste, example change particle size, etc. So this depends on the type of waste that is received. Then stabilization is usually followed by solidification. First you stabilize the waste and then you solidify it, right? So solidification refers to technique that maybe encapsulates the waste in a monolithic solid of high structural integrity. something like you, what to say, if it is in a liquid form or a semi-solid form, you make it as a solid, so that it is easy for you to transport it, handle it, and all those things. Stabilization is the most important part. It refers to techniques. There are several techniques under that, as I told, that reduce the hazard potential of the waste by converting the contaminants into the least soluble or mobile or toxic or any lethal form. So this is not the final treatment. This is always considered as a pre-treatment process to the disposal or landfilling process. This should be kept in mind. So as I told, SS is nothing but solidification and stabilization. So it's a pre-treatment prior to landfill. This also needs a lot of study, because each and every type of waste is totally different. Supposing you're getting a what to say, waste from the paint industry, you're getting a waste from the petroleum industry, you're getting a waste from the tannery industry. Obviously, each and every one of it will have a different characteristics. So it is, what to say, usually recommended to have a bench scale study or a pilot scale study for some time, to have the long-term effects or to analyze the long-term effects on the environment. Then you have to decide the end uses based on the long-term effects only. Then hazardous and non-hazardous waste having no leaching properties are good candidates for solidification. So the compounds which don't have these characteristics, that can be used directly for stabilization or solidification. So what are the factors affecting the leachability of the waste? Because that is a most uh, important characteristics through which the contaminants or the toxic compounds enter the environment from the hazardous waste. So one of the things is the alkalinity of the waste. So then surface to volume ratio of the waste, then leachate to volume waste ratio, type of leachate, pH of leachate, contact time, extent of agitation, number of replacements of fresh leachate, extraction vessel, temperature. So all these things play a very, very important role in leaching of the particular toxic compound or the element. So we have to consider all these things when we are studying about the toxicity of the waste. So these are applicable to different categories. You might have heard of some gas leak in Vizag during this lockdown. So that was also one of the hazardous gases. So our team from NEERI, they went and they tried to stabilize it. So it was a gas that had settled down with a very high specific gravity or density. It had settled down up to 2 feet from the ground. So what these people did, they analyzed it and they sprayed some kind of a chemical which will precipitate with it or react with it and form solid precipitates and settle down on the ground. So that is how these people worked out on that. And then later on, when it settled down, the soil or the top layer up till the 1 or 2 feet was removed. And then it was removed and it was taken to a landfill. Still, there are some tests going on to what extent it has been spread and all those things. But I'm just giving an example. So as I told, the waste streams and the recommended treatment methods. Say, for example, if your waste stream contains mercury, then solidification and stabilization is recommended. And even in stabilization, there are different methods, like I told, chelation, complexation, precipitation. So that is further studied, and whatever chemical method is suited for this, that is taken up. So again, selenium, silver is the same thing. So when it comes to wastewater sludges, it is like alkaline chlorination. Why alkaline chlorination? Because the wastewater sludge contains a huge amount of bacteria or the microorganisms like E. coli and all those things. So once you remove it through chlorination is a disinfection process. So then you chlorinate it, remove it, and then you precipitate it. That is how it is. So again, spent cyanide plating sludge and bath solutions. Again, the same procedure is followed. Again, here also the alkaline chlorination helps in, because it is in a very acidic thing. So this alkaline chlorination helps in stabilizing it. So lead stream, again, solidification, stabilization. So process waste from pesticides, chlorinated hydrocarbons. So it is incineration plus SS. And then still bottoms from process. So this is like the slag might be one of the examples, the bottom remains of the processes. So again, you have to incinerate it, and then you can follow SS. So coming to, we saw the pre-treatment methods, then we saw the characteristics and all those things. Some of the disposal methods. Now, after pre-treatment, it has to be disposed, right? So some of the pre-treatment methods include surface impoundments. Surface impoundments is nothing but, you can see in the picture, you have a, what to say, kind of vacant area where it is lined properly, and then you put the liquid hazardous waste here to store it. So maybe, it evaporates after some time, right? Or it doesn't, definitely it doesn't, what to say, percolate the soil or the, what to say, bottom, this thing, but it definitely evaporates. But again, this is again a problem because it evaporates and it again keeps on circulating in the environment. So that again, when there is any rain, or when it mixes with any form of chemical in the atmosphere, again it comes back to the tank. So this is not recommended, but where there is no option, they go for this. So the what to say, the clay layer can crack and leak waste, they say this. But usually nowadays what they're doing is, they're not putting a clay layer, they're putting a what's it say, HDP liner. HDP is nothing but high density polyethylene membrane. They usually use it. It's a 6 mm 2.5 mm thick material. So they use it, double liner they use it. So there is a very little what to say, chance of leaking it. Then another method is deep injection, deep well injection. So they just drill a well, they inject the liquid waste into it. So something like a well, very deep well, you put your waste there and then it remains there. This is one of the methods. But again, there is a risk of, what to say, polluting the intermediate, what to say, as it is shown here, the soil layer or the water layer or whatever it is. So coming to the next thing, they finally, what to say, take all the waste after the pre-treatment to a hazardous waste landfill. Now, a hazardous waste landfill has a lot of, what to say, design criteria. So what are the tasks that have to be, what to say, carried out before designing a hazardous waste landfill? The hazardous waste landfill and a municipal solid waste landfill are totally different, and the rules are very stringent in the case of hazardous waste landfills. So first is the determine the solid waste quantities and characteristics. Maybe what is the amount of thing that is going to come. Maybe you are having an industrial area, then you can what to say, calculate. So this is all what to say, done. Like for example, I think in Bangalore there is a this thing in the outskirts of near Tumkur. There is a hazardous waste landfill. So they usually have it in places where there is a, what to say, industrial area, very populated industrial area. One of the very polluted and populated industrial areas and hazardous waste landfill is in Ankleshwar, Gujarat. So it's a very populated polluted area. Once you walk into the area, you can see only the what to say, black colored soil or the gray colored soil. You won't find the natural soil there. So it has been polluted to that extent. So you have all those industries, so you can obviously calculate what is the amount of solid waste that will come in the future, and then based on that you can design your landfill, because until unless you know the capacity, you won't be able to design it. Then perform the boundary and topographic survey. So this is very important because whether you're having any surface water body near it, or any other what to say, important form, natural form near the in the vicinity, if it is there, then it has to be rejected. You cannot have your landfill site there. Then you have to prepare your base map of existing condition on the site and near site. Then property boundaries, maybe it involves all the legal things. Maybe you have to, if you want to take some legal permission from some authority, all these things come into this property boundaries. Then topography on the soil, this is basically related to the what to say, elevation, mean sea level, and all those things, and slopes. Then further it includes like surface water bodies, utilities, maybe infrastructure, buildings, and all those things, roads, structure, the land use pattern there. Then after this, you compile the hydrological information, because groundwater is one of the important sources, although also the industries use it, so it shouldn't be polluted. So you have to compile the hydrological information. Say if it is a groundwater, then there is an aquifer, then how long is it, I mean how beneath is it, how depth, what is the depth of that, then all those things, what is the recharge capacity of that, other properties of that. So all these things have to be found out first using a map or other means, GIS or whatever means it is. Then you have your soil. Then soil, there is a lot of things, because naturally available soil, they make use of it for a number of purposes. So for example, depth of the soil, natural soil, texture of that, whether it is a, what to say, loamy soil, clay soil, silty soil, what type of hazard, then structure, then comes to density, porosity, permeability, moisture, ease of excavation, stability, pH, cation exchange capacity. So all these things come under the soils what to say category. So if you're doing a soil test, then you have to do all these things. Then comes the bedrock. If there is a what to say rock type structure, then what is the type of rock, what is the depth of rock, to what depth is the rock there, then presence of fractures. The fractures is very important, because if you're dealing with any leachate thing and all those things, then the fractures are very risky and dangerous. The leachate, it will percolate through the fractures and it will directly go to the nearby groundwater bodies. That is why it is very important. Then groundwater, as I told, average depth, what is the seasonal fluctuation, average rainfall and all those things, gradient, etc. So then you have the climatological data. So what is the climatological data? It is the precipitation, that is the average annual precipitation, rate of evaporation, temperature, freezing days. Of course, it won't count in India, but in hilly regions, it is a very important factor. And then wind direction. So all these data nowadays, you can get it directly from the net or Google. So you have to consider all these data before designing a landfill facility. Then regulations. So federal, state, local, central, state, local. So you have what to say hazardous waste regulation. You know that, right? So there is a manual given by CP. So in that there'll be what to say different, for example, liner composition, cover composition, and what are the what to say conditions where you should have a hazardous waste landfill, are all what to say listed out there. So you have to refer to that before designing it. Then after that, once you do all these things, then you go into the real designing, that is designing the filling area, like say site topography, what to say slopes, the basically the what to say outer structure of the landfill. Then once you design this, then you go further into it, like the whole of a landfill is divided into different trenches, different cells, and then what is a fill depth, then you have your what to say leachate thing and all those things, leachate collection systems. All these things will come under this specific dimensions. So now I'll just show you a case, like waste collection. You can see here there is a what to say location is there, waste collection is there, then this is the what to say generation, waste generation. Then what is a topography? It is a variable ground. What is a subsoil? Hard grave soil, gravel soil underlain by bedrock. Then what is annual precipitation? Groundwater is at 200 depth. So something like that, you have to get all the site characteristics. Then when it comes to design, there are three important factors, like landfill capacity, liner system, and leachate collection system. So based on this, you design the what to say life of a landfill based on the future capacity. As I told, the daily input, and based on that, you see for how long it will be able to serve the purpose. Something like this. Then you have the capacity, like waste generation per day, assuming that this is an example I'm giving. So 100 tons per day. Then area at the top, this is, so this that the landfill is, it might be below the ground, it might be above the ground, it might be both. So here it is both below the ground and above the ground, right? So this is landfill area available at the bottom, then depth provided 25 meters, then total what to say area available, then volume, and based on the tons, then total waste generation in 10 years, something like that. So this is the standard thing you have to calculate. There is a simple calculation method given in the manual also, but in case of hazardous this thing, you have to calculate like this. So something like a cross section like this. So this is a variable ground, as I told. Here the level is very high, here it is very low. So here what to say, this is 18 meters, this is what to say maybe 9 meters. So we are planning to construct a landfill like this on top of it, right? So something like this, you have to get the details of the site. Then what will be the depth? Something like 18 meters from this side, and from this side maybe 9 meters below the ground, and from here again it will be maybe 18 meters. From here it will be maybe 2-3 meters so above the ground, right? So like that you have to, this is very what to say site specific and case specific. So you have to design in each and every case, every landfill. So coming to the liner and cover system, so you can see this cross section here. So this is waste. Top you have the cover system, bottom you have the liner system. So in case of what to say hazardous waste landfill, you have both HDP liner in the cover and the liner system. In fact, in the liner system, it's a double liner system. So double liner system is nothing but you have two HDPE membranes, right? So in case of municipal solid waste landfill, you don't have a HDPE membrane in the covers. So if we start, this is a vegetation layer, maybe around 30 centimeters, then topsoil around 30 centimeters. Then you have a drainage layer. Drainage layer is nothing but a layer wherein the water that percolates from here, it is collected in the drainage layer. You have pipe system there, and then it is taken to some kind of collection storage. So this HDP membrane is placed below because this is very what to say impermeable. So the permeability of this HDP membrane is around 10 power minus 14 centimeter per second. So you can imagine it's almost impermeable, right? So that is why it is placed here. So whatever water enters through precipitation or any other manual process, it just goes through this and is collected in a storage tank. Then you have a clay layer. So usually nowadays geosynthetics are playing a very huge role in this landfills. So maybe instead of a clay layer of 60 centimeters, they are having a GCL also. GCL is nothing but a geosynthetic clay liner. So they are having that also. Maybe it is around maybe 5 centimeter thick. So you can have two layers of GCL, something like that. Wherever the native soil is not available or clay is not available, or the transportation cost of clay to the site is very high, something like that. Then you have this gas collection system. So this gas collection system, I wouldn't go into detail, but I'll just give you a rough idea of what it is. So there are what to say two types of gas collection systems, that is active and passive. So active is that you have some kind of mechanism to remove the gas. Passive is just you just leave it, and the gas when it is generated, it just comes out of it, because there is no other way to move out of the landfill. It has to obviously move out like this only. So it goes into this layer. So for example, if there is any gas generated from here, so it will go through it, and finally it will go through here. So once after it comes here, there are different methods of what to say dealing with it. Maybe you can flare it if the if it is not of any use. If it has good what to say content, like say for example methane comes out from municipal solid waste landfills, they collect it and they send it, pass it through a genset, and then they convert it into electricity, though the conversion efficiency is very less, something like less than 30%. So here they have a gas system. Usually they go for flaring. Flaring is nothing but the gas, when it comes out, there'll be a small spark that is introduced into it, so that it burns completely, and when it goes out, it doesn't go out as the harmful gas. It just goes out as what to say, maybe some lower forms like carbon dioxide, etc. Right? So this is a soil cover. Then you have the waste. Then after the waste, you have this geotextile. This is just a separation layer between the waste and the bottom layers. Right? Then you have a drainage layer, the same what is it, drainage layer that you had here, 30 centimeters. Then you have a primary HDP liner. So this HDP liner is 2.5 mm thick. And then you have a geosynthetic clay liner, as I mentioned, 7 to 8 mm thick. So after that, again, you have a leachate collection system and detection system. So you have these are pipes. I'll just show you how the pipes are, how it is what to say looks like in a field. So then you have your clay liner, and then you have your substrata. And just after the clay, again you have a liner. So this is the what to say detail liner system for a hazardous waste landfill. So it is again the same thing in a what to say detailed manner. So these are the pipes, these are the what to say waste. You have a geotextile, then you have the gravel packing, then the pipe. So the gravel size is also listed, like 100 gravel and all those things. Then you have a HDP membrane, again a separation geotextile, then a gravel packing, then HDP membrane, then again a what to say compacted clay liner. So this might slightly vary with respect to the site. So coming to the CPCB system. So what I would like to say what to say the liner system that is given by the CPCB, it is there. But is it really what to say successful, or will it really stop the leachate that is coming out of it, coming out of the waste? Say for example, this waste is there, and that there is a leachate that is coming out. So you have a collection system here, you have a collection system here, but will it really what to say stop the leachate if in case there is any what to say crack in the system? Because you're placing a huge amount of waste or weight over here, so there is a considerable amount of mechanical stress that is on these layers. So maybe there is a chance that it might get leaked. So for doing that, you can use some softwares. So what we usually do is we usually use two softwares like Help and Pollute. So Help is nothing but hydrological evaluation of landfill data. So you will just come to know what is the amount of what to say leachate that is generated after some particular amount of time. Say for example, this is the years. So for example, 10 years, what is the amount of leachate generated in the waste? So if you give the category of waste, this software has that option of giving the category of waste. So if you give the hazardous waste category, then it will just show based on the what to say precipitation, climatological conditions. It will just calculate and it will just show. So here in this case, it is like maybe 1.5 or 1.4 meter cube of what to say leachate. So it is very less compared to the total quantity. That much will be generated after a period of 10 years. So this is per day, right? So this is something like that. So this is very very important tool or a useful tool for us to what to say design the leachate treatment system. Because until unless if you know the total quantity of leachate that is being generated, it is very difficult for you to design a what to say leachate collection system. So for example, I can tell you, give you a lot of examples. Our Bangalore only, Yelanka Mavalipura site, there is of course it is not a hazardous landfill, but it is a what to say municipal solid waste landfill. I'm just giving an example of wrong design. So what these people design, I don't know how these people design. So they just designed what to say capacity leachate treatment facility and storage of 1 lakh per day. So 1 lakh liters per day. But what happened is like when there was rain and during monsoon, it was around what to say 8 to 10 lakh liters per day. So these people didn't know what to do. All of the leachate was getting out of the site and it was getting mixed with the natural soil, natural water bodies, etc. So that kind of thing shouldn't happen. So it is better to quantify the amount of leachate before designing the this thing facility. So one more this thing is the pollute. Pollute will give you the what to say specific metal or what to say whatever component you choose, organic, inorganic. So it will maybe say you're choosing chlorine, so you need to give the concentration of chlorine. Need to give the necessary details for the what to say liner system. So it will just calculate and show maybe after some particular years, 30 years, will it really go through that depth, or the liner, will it pass through the liner, will it be or to what depth of soil it will be percolating. So this is again a what very very useful tool. So help us for quantification. This is for the particular element. Say for example, in this case I've just taken chlorine. So you can say, you can give all these parameters, what is a leachate head and all those things, density, mass, all those things. So it has what to say all these inbuilt characteristics. So once you know the what to say thing values, you can enter the values and then it will give a this is the what to say example. So you can just see I don't know whether it is visible for you, but I'll just show, I'll tell you. So I've just analyzed for 5, 10, 15, 20 and 30 years. So you see 30 years. After 30 years, so this is the what to say depth of 20. So here it is 20 meters. So it says that even in the presence of a liner system, your pollutant, that is chlorine, it will go through the liner system and it will go to a depth of percolate to a depth of 20 meters. So that is the what to say analysis. So this will give you a rough idea, like if the say if the in this case the water table is below 200 meters, so there is no problem as such. But if you're having a what to say maybe water body groundwater source at 50 meters or maybe 30, 40 meters, then it is highly risky. You shouldn't be choosing that site for a landfill facility, something like that. So you can analyze like this. So After that, once you design the, get into the quantification and the characterization of this, then you can go for the design of slopes. So there are again some softwares being used. You might be aware of this, slide and all those things. So just to make sure that, if you're constructing above the land, it doesn't fail because of some kind of external stress or other, because there will be a lot of characteristics or activities happening in the landfill or near the landfill. So just to make sure that it doesn't fail at a later stage. So this is a a rough diagram of a case. So this is phase one, phase two. This was a site specific characteristics. So as I told, like one side there is a level is like uneven. So accordingly you design it, right? So this is that slope stability analysis. So this anything above 1.5, so factor of safety 1.5 is considered to be safe. So this is the slope above the ground that you're giving. So in this case, it is I think 1.2, so 1.3. So 1.3 is safe in this case. So anything less than 1.5 is not safe. So you can analyze and then you can accordingly design your slopes. Something like this. As a top this thing. So this is the final thing that we had designed. So here we are providing that on 1:3, 1:3, 1:3. Sorry. So 1:3, 1:3, and then this is a design. So once we have arrived with this design, this is a volumetric design. Volumetric design is nothing but the external dimensions of the landfill. Now when we go inside, there are different components like the gas collection system, leachate collection system, and all those things. So we'll just go see that. So coming to the leachate collection system, so you can see all these parameters are considered, and it is very very important in determining the leachate collection facility. So rainfall at the landfill site, surface runoff, groundwater, evapotranspiration, degree of compaction, field capacity, etc., etc. So all these things are given in a manual, right? Something like that. So then we designed a leachate collection system like this. So the what is the plan area of the landfill? It is around 22,000 meter square. Then annual precipitation in Bangalore. Then 80% in precipitation in 4 months. So sorry. So accordingly, you have estimated this much of leachate. Then coming to the collection pipes. So the HDP pipes. So these are HDP percolated pipes that are placed. So you need to have around 150 diameter pipe because you are getting that much of leachate per day. So accordingly, it is designed. So then total length. So total length is calculated based on the total area of the landfill. How many connections you want to have and all those things. There is a separate rules accordingly given in that. Say for example, in 1 acre you can have four injection wells and then leachate collection pipes like that, right? Then you have the diameter of the leachate collection tank, height of the leachate collection considered, and all these things. So number of tanks, how much of the number of tanks needed, and all those things. So you can design like this. So this is like something like you're considering it 2 times so that it will be safe. So this is a drainage system. I'll just show you the picture. So it is just mentioned like what is the slope at the bottom of the lateral pipes and all those things. So this is the drainage system. So that is a collection system. Then this is a drainage system. Something like this. So you saw that design. So in this design, we are placing this many horizontal pipes and lateral pipes. So this is the horizontal pipe one, and these are the lateral pipes. So what happens is there is a slope that is provided here at the bottom, say 2% slope. So what happens is all the waste, all the water gets collected in this pipe through the lateral pipes, and it is finally taken to some kind of collection system. So this thing, it will be like this. So here we have we have a spacing of 20 meters, and then we have this 150 mm perforated pipes. So like this. So here is one pipe, and then you can see here is one pipe. So this spacing is 20 mm, right? So this will take to a common pipe, horizontal pipe that will be here, and this pipe will be taken to the collection system, something like this. So this will be built at the bottom, something like this. So this one horizontal pipe will be connected to number of lateral pipes, and the leachate will be collected here. So here after this, the leachate might be treated at the site, or it might be taken to a effluent treatment facility. It might be transported to a effluent treatment facility. So that depends on the site how they are going to deal with that. So major thing is like according to the rules, they have to collect the leachate. So if they are sending it to a leachate effluent treatment facility, that is fine. Or else if they are treating it themselves like solidification or stabilization, that is also fine. So it depends totally on the site. Coming to a landfill, land management plan. So this is also very important once you do the leachate management, because the landfill is active throughout the year, and during the season, maybe there might be incidents of fire or some kind of other explosions in the landfill during the peak over generation of leachate during the monsoon season. So for that, how do you go about it? How do you cover it? All these things are given in this. So you consider all these things as I told before. I'll just run through it because I think I'm running out of time. So I'll just show you only the picture diagrams. So you need to have a ramp in whatever facility, either it be a municipal solid waste facility or a hazardous waste facility, because only through the ramp you can enter, you can deposit the waste to the bottom, and then you can come back. This ramp is not required if you're having a landfill. So that ramp is required here. So it will be filled in strips. So strip 1, strip 2, maybe the size of the strips may vary starting from 3 meters to 10 meters. That again depends on the landfill site. It is site specific. So there might be a working phase, there might be a closed phase. The cell 1 is being filled. So then all these things should be covered with a HDP liner or a geotextile, so that the water doesn't enter or percolate through it. So all these water, when there is a precipitation, will be a runoff. So the order of filling should be something like this. In this, then this. So once these cells and this layer is complete, then you close it. This is how it is done. And so yeah. So any questions?
Yeah, if anybody has any questions, kindly unmute and ask. No one has any questions? Okay. Sir, it looks like nobody has any questions.
Yeah. So hopefully they have understood. Either they have understood or they have not understood completely.
Yeah. Anyways, sir, thank you very much, because the topic is of great relevance for these students, because they have not yet started with their project works. So they will get a lot of inputs regarding research areas for their final year projects. So from the Department of Civil Engineering and on behalf of all the faculty and students, thank you once again, sir. Thanks a lot.
Thank you, madam. Thank you.
Sir.
Yeah.
So I think all of you can exit now. The feedback form is will be sent to your mail. Kindly fill it.